Okay, good day everyone. For this video, we'll be discussing one of the topics for Module 9. So, one of the three topics of your Module 9 is all about the remainder theorem. But before we discuss the remainder theorem, let us have a review first about the synthetic division. Okay, so let's get started. Okay, so what is a synthetic division? A synthetic division is a shorter way or a shorter procedure when a polynomial is to be divided by a binomial in the form x minus r. X minus r is our divisor. Okay, so let us have an example. We have 3x cubed plus x squared minus 22x minus 25 is divided by x minus 2. Or what is the quotient if 3x cubed plus x squared minus 22x minus 25 is divided by x minus 2. Okay, so let us now apply the shorter way, which is the synthetic division. Okay, so we have here another word so that you can easily compare our solutions. Okay, so example, we have our given example is 3x cubed plus x squared minus 22x minus 25 is divided by x minus 2. Okay, so x minus 2 is our divisor and 3x cubed plus x squared minus 22x minus 25 is our polynomial. Okay, so in applying the synthetic division, first we'll write the coefficients in this manner. We have the divisor. For the divisor x minus 2, we will equate x minus 2 with 0. So we have x minus 2 is equal to 0. So we're going to transpose negative 2, so it will become, or let's say, take the opposite sign of negative 2. So the opposite sign of negative 2 is positive 2. So our value of x for the divisor is positive 2. So we'll just write positive 2 here. And then for our polynomial, we're just going to write all the numerical coefficients of x's. Let's say for x cubed, the numerical coefficient is 3, and x squared, the numerical coefficient is 1. So as you can see, there's no 1 as the numerical coefficient of x squared, but it is understood that the numerical coefficient is 1. Okay, so you're going to write 3, then for x squared, the numerical coefficient is 1. Then for negative 22x, the numerical coefficient is negative 22. And then the constant term is 25 or negative 25. Do not forget the sign. Okay, so in using the synthetic division, in writing the numerical coefficients, make sure that the degrees or the exponents must be in descending order. Let's say we have a 3, then 2, the next is 1, and last is the constant. Okay, so example, our given is 3x cubed. Let's say there is no x squared, so our given is 3x cubed minus 22x minus 25. So it should be arranged in descending order, the numerical coefficient. So in that case, example, there is no x squared here, you're going to write 0 x squared, so that our exponent will be in descending order. Or later I will give you an example about this one. Okay, so let us start. Let us apply the synthetic division. So applying the synthetic division, first step is you're going to bring down positive 3. Okay, after that you're going to multiply positive 3 to 2. So 3 times 2 is 6. Then you're going to put the answer here. Okay, And then afterwards, you're going to add 1 plus 6, that is 7. Okay, 7 is the answer. And then repeat, 7 times 2 is 14. Again, write the answer here. Then add negative 22 plus 14. So negative 22 and positive 14. Unlike sign, you're going to subtract. So 22 minus 14, that is 8. And then what is the sign of the bigger number? The sign of the bigger number is negative. So we're going to write negative 8. Okay? Then afterwards, multiply again. Negative 8 times 2 is negative 16. So you're going to write negative 16. Okay? Then add. We have negative 25 plus negative 16. So negative and negative like sign. So we're going to add. 25 plus 16 is 41. And then copy the common sign. The common sign is negative. So negative 41. Okay? So now, how are you going to write your answer? So since the highest degree of our polynomial is 3, just subtract by 1 sa ato ang answer. So, sa ato the results here are 3, 7, negative 8, and negative 41. So, we're going to put the excess for the coefficient, I mean the exponents of our answers. Let us subtract with 1 sa atong highest degree sa polynomial. So the highest degree is 3. So we're going to subtract 1. So 3 minus 1 is 2. So 2 will be the exponent of our degree. I mean the first term here. So we have 3x squared, then positive 7. So in descending order, we have plus 7x. So 2, 1 here. And then negative 8 is the constant, negative 8. And then the remainder is negative 41. This is the remainder. The remainder is negative 41. So how will you write the remainder? We're just going to add plus or add negative 41 over the divisor. The divisor is x minus 2. So we have x minus 2. So your answer now is 3x squared plus 7x minus 8 plus negative 41 over x minus 2. That is now the answer. Okay, so here's another example. So we have here 2x cubed plus 3x minus 6 is divided by x plus 1. Okay, so as you can see in our example, the exponents are 3. For 2x cubed, the exponent is 3. Then for 3x, 1. Then the constant is negative 6. Okay, so what is missing is the degree or the exponent 2. So in that case, we're going to put a term which has a degree 2. So we have 2x cubed. So we're going to add 0x squared. 0x squared as the term which has a degree 2. So it cannot affect our polynomial expression because that is 0, because of the numerical coefficient 0. So this is just to emphasize that the degree must be written in descending order. So we have 2x cubed plus 0x squared, and then plus 3x minus 6 is divided by x plus 1. Okay, so our polynomial expression now is in descending order, or the degree or the exponents are in descending order. We have 3, 2, 1, and the constant. So next step is we're going to equate x plus 1 with 0, or just simply take the opposite sign of positive 1. So the opposite sign of positive 1 is negative 1. Okay, so negative 1 should be written here for our divisor. And then next step is write the numerical coefficients of each term. So for 2x cubed, the numerical coefficient is 2. Then for 0x squared, the numerical coefficient is 0. And positive 3x, the numerical coefficient is 3. Then write the constant term. Okay, so first step again, in applying the synthetic division, we are going to bring down positive 2. Then multiply positive 2 by negative 1. So 2 times negative 1 is negative 2. Then add. We have 0 plus negative 2 is negative 2. Again, repeat the process. We have negative 2 times negative 1 is positive 2. Negative times negative is positive. 2 times 1 is 2. Then add again. We have 3 plus 2 is 5. Then multiply. 5 times negative 1 is negative 5. Then add. Negative 6 plus negative 5 is negative 11. Okay, so negative and negative, like sign, add. So 6 plus 5 is 11. Then copy the common sign. The common sign is negative, so negative 11. Okay, so again, how will you write your answer? The highest degree is 3. So the highest degree of our answer or of our quotient must be 2. So we're going to write the numerical coefficient is 2, and since the highest degree is 3, so subtract by 1, so we have x squared. Then descending order, we have negative 2, negative 2, then x 2. Then it is understood that there is 1 here as our degree or exponent. Then the constant term is positive 5, so plus 5. So this is now the remainder. So the remainder is negative 11. So how will you write the answer? Just add negative 11 over what is our divisor? Our divisor is x plus 1. So x plus 1. Our answer now, or the quotient of 2x cubed plus 3x minus 6 divided by x plus 1 is 2x squared minus 2x plus 5 plus negative 11 over x plus 1. Okay, so we are now done with synthetic division, a sort of review. So let us now move on to the remainder theorem. So remainder theorem is one of our focus for this video. Okay, so if the polynomial p of x is divided by x minus r, the remainder r is a constant and it is equal to p of r. Okay, so the remainder theorem, the simplest definition is that remainder theorem is just the simplest way in determining the remainder. We have let's say if p of x divided by x minus r, the remainder r is a constant and it is equal to p of r. The remainder is a constant. Okay, example, find the remainder when 5x squared minus 2x plus 1 is divided by x plus 2. So our divisor is x plus 2 and our polynomial is 5x squared minus 2x plus 1. Okay, so applying the remainder theorem, or in getting the remainder, if we're going to divide x plus 2 to 5x squared minus 2x plus 1, applying the remainder theorem, first we're going to write the polynomial. The polynomial, we have p of x is equal to, again, the polynomial is 5x squared minus 2x plus 1. This is now our polynomial, p of x. The next step, our divisor is x plus 2. So next step is we're going to find the value of x from our divisor, which is x plus 2. Okay, so x plus 2, this is the divisor. We're going to equate the divisor with 0. So we have x plus 2 is equal to 0. Then we have transpose positive 2, that is x is equal to negative 2. Or just simply take the opposite sign of positive 2, that is negative 2. Okay, so next step, we're going to substitute negative 2 to all x's. So we have p of x. Again, the value of x is negative 2. Then we have the polynomial 5x squared minus 2x plus 1. We're going to substitute all x's with negative 2. So we have negative 2 squared minus 2 times negative 2 plus 1. Okay, the next step, just simplify. We have p of negative 2. By the way, this is read as p of negative 2. This is a polynomial. Then we have 5. Simplify first what is written in the parentheses. We have negative 2 squared. That means negative 2 times negative 2. So negative 2 times negative 2 is positive 4. So it will become positive 4. Then here we have negative 2 times negative 2. Negative 2 times negative 2. Negative times negative is positive. 2 times 2 is 4. Okay, so that is positive 4. Then plus 1. Again, simplify what is written in the parentheses. So we have 5 times 4 is 20. Then plus 4 plus 1. We have p of negative 2. Simplify or add or subtract from left to right. We have 20 plus 4 is 24. Plus 1 is 25. So the remainder now is 25. This is now the remainder. The remainder is a constant. Okay, so let us try to check our answer if it is correct. If the remainder is 25, we're going to divide 5x squared minus 2x plus 5 with x plus 2, or by x plus 2. Okay, so let us try to check if we'll get the correct answer. We will check our answer applying the synthetic division. Okay, so again, our polynomial is 5x squared minus 2x plus 1 is divided by x plus 2. Okay, applying the synthetic division, take the opposite sign of positive 2, it will become negative 2. Okay, afterwards, write all the numerical coefficients of the polynomial. So we have 5, negative 2. It is written in descending order already. So 2, 1, and the constant. So negative 2 and the constant is positive 1. Okay. Next, bring down 5. Bring down 5, then multiply 5 to negative 2. 5 times negative 2 is negative 10. Then add negative 2 plus negative 10, like sign, add 2 plus 10 is 12. Then copy the common sign. The common sign is negative. So negative 12. Negative 12 times negative 2 is positive 24. So negative times negative is positive. Then 12 times 2 is 24. Okay? By the way, no need of writing positive because it's understood that 1 is positive. Okay, so add 1 plus 25. That 1 plus 24 is 25. Okay, so how will you write your answer? We have the highest degree is 2. So the highest degree of the quotient must be 1. So we have 5x raised to 1, or 5x. Then the constant is negative 12. Now the remainder is this one, positive 25. So how will you write the remainder? We have plus 25 over the divisor is x plus 2. Again, the remainder is positive 25. So we got the correct answer, 25. Okay, so that's all for the remainder theorem. Okay, so that's all for the remainder theorem. God bless everyone.